One of the things that Phil wanted everyone to do was learn how to cut discs. Because if you're going to be a mixer at A&R, he felt like you can't be a mixer at my place if you don't know what the limitations of the vinyl disc are. You've just got to know that. So everybody spent a certain amount of time in the disc cutting room learning how to do it. The guy that taught me was Jay Messina. And Jay, of course, went on to become a superstar independent engineer with Supertramp and people like that, and had his own studio. At any rate, so Jay is there, and he taught me how to cut records. You need a lot of patience to be a disc cutter. You need to be able to cut a 24-minute side and do all the moves perfectly, and if you lose chip in the 23rd and a half minute side, you got to start over and do the whole thing and not totally freak out and throw discs against the wall. You've just got to be a patient person. And I had all that patience. So A&R had a mono Neumann cutting lathe with an ES59, I think it was, cutter head. It was a very good cutter head to this day. I mean, it's an excellent mono cutter head. Took plenty of level. It was great. On the left side was an Ampex 300, the one that has a button and a selector knob. You'd select whether you wanted to wind or rewind or play, and there was basically a stop, or you'd hit the button that would select whatever you had on that selector there. And then we had a record machine next to it for making tape copies. And then the little console we had an Altec limiter, maybe an RCA de-esser or some homemade thing or some Gotham thing. It had some Gotham audio electronics on it, and but it cut good sounding discs. It was good, but it was a fixed pitch lathe. If you wanted to cut a 45, you would open up the side and pull out these gears that would give you 86 lines per inch. And if it was a really hot record and a short record, that's why all the records are under 3 minutes, right? And then if you had to go longer and longer, you would use higher gears like 132, and then you'd get into the LP things. And of course, with a fixed pitch, every groove was equidistant from the other grooves. And if you're cutting the record and something has big bass, you know, it would just go like that between the grooves. And if there was nothing to stop it from just completely either kissing or crossing over the other groove, thus records got the reputation that, oh, you've always got to limit the bass a lot or cut the bass. And even with mono records, that was what it was. And of course, you talk about the loudness wars today. It existed back then. Jay taught me all the basics that I knew about mono disc cutting. Then A&R got a lathe. They were the first independent studio, I think in America, to get a computerized stereo disc cutting lathe, the VMS 66. And this was an analog computer that was on this lathe, not a digital computer, an analog computer. Analog computers have a great place in our world because if you study how string theory and chaos theory before that got started, it turns out that all the work on fractals that led to it really only were easily possible by use of an analog computer. Phil says, look, okay, Aaron Barron, the maintenance guy, and Bob, you're going to the stereo lathe. We're locking you in that room, and don't come out until you know how to make it work and really work well. So Aaron and I are in the room trying to figure out, and so I taught myself really how to do this. Aaron and I together, a lot of the mechanics, you know, disc cutter, every time a record would come out on CBS, I'd look and see exactly how they did the grooves and how big a spiral they used and how far away from the label they stayed. And, you know, so a lot of what I did, I learned from copying what the union guys had been doing, because obviously that was the way that worked for them. So, but the main thing was the pitch and depth system on this lathe. If you set it up according to the way Temer told you to do it, it wasted a lot of space. So we kept readjusting it and readjusting it and readjusting it. So the room had the lathe on the left when you came in, and above it were two 604E Altecs in the old gray cabinet, and to the right was a big cabinet with all the stuff in it, And then there was a Scully 4-track tape machine that was the stereo playback but had 2 extra tracks for the preview head. Like the Neumann AM32B lathe that preceded it, that was a lathe that had variable pitch that the Scully lathes also had, that was kind of, they had a preview head on it that sensed the music before it got to the playback head that fed the cutter head. So it would get this thing and it would be like, oh, it's loud, I better expand. So these things would expand and the loud part would come, and then it would be quiet and the thing would, the grooves would come back together again. The idea with the computer lathe was that it could just do the same thing except much more efficiently. And to skip ahead of several years, that cutting system got really efficient. A guy named John Bittner invented a thing called the Zuma disk computer, and then later Telefunken and Neumann came up with an equivalent thing for the VMS-80 that was incredibly accurate. It was so accurate that if you had to determine the absolute phase of the system, because if it wasn't an absolute phase, the cutting system couldn't nestle the grooves. You could cut certain grooves, I think like 100 cycles, that were harmonics, where you would cut a groove and the next groove would nestle right next to it, and then all of them would cut in a pattern like that. I mean, it's like perfect efficiency. So by about 1974, that aspect of disc cutting got as good as it ever could possibly get. There was no more improvement. That was done. The only thing that would improve the preview systems at that time was the speed that the grooves came apart for the preview system. And it turned out that you could drive the system so fast that you could actually modulate the groove. You'd hear the modulation before the groove as it expanded. So, as I say, it reached perfection. There was no more development to be done in that area. But backing up, so the console at A&R had all tube gear, except I believe we had Longevin line amps in there. And we used Pultec EQs, and I had these Fairchild disc cutting limiters that you could use sum or difference, and length left and right or separate left and right. It's the famous Fairchild that goes on eBay for $35,000 now. And I remember using that for disc cutting, and it worked fine, but that compressor, like the Telectronics or the LA3As, all those compressors, they would change their response a bit as they compressed more and more. That was part of the optical system in there. It would change its frequency response. So for me, I wasn't that knocked out with the Fairchild limiter for cutting, and I couldn't wait to get rid of it, to tell you the truth. And with our great maintenance staff there, everybody had manuals for everything, and I'd be reading the manual for every piece of gear I had, and I'm looking at the Fairchild limiter, and I'm looking under distortion, and it says that the distortion specification for the Fairchild limiter was 1%. It's like if this thing was anything better than 1%, it was okay. I thought, well, that's not very good. And sure enough, it turns out that with disc cutting, as you get towards the inner bands, towards the label, as the disc material is revolving slower and slower, the disc rotates at 33 1/3 RPM, but the outer part of the disc goes about 19 inches a second of material, and on the inside it's about 7.5 or 8 inches of material. It's a huge degradation in amount of material that you can inscribe grooves into. So there's high frequency loss and all these things that happen, but for sure the thing that happens the worst is once you get past the 6-inch diameter, the distortion goes up incredibly. And you can imagine if you kept cutting into the where the hole of the record is, it would reach infinite distortion. So it turns out that if you're recording on a system that's got inherent distortion like this to begin with, that it's very important to have a very clean signal, to have those inner bands be clean. Because if you have 1% distortion in your Fairchild compressor, you get into those inner bands and add another couple of percent, you're getting pretty audible pretty soon. The thing that was very interesting is that we couldn't get that thing to work. And one day, I'm working on the Scully machine, and I just said, look, let me just back the preview off a couple dB and see what happens. So we cut a disc with the preview backed off 2 dB, and lo and behold, the thing starts cutting really well, and it didn't seem to affect, something about that did something that didn't affect the alignment that we had done, and the thing started cutting like it really ought to. And so, pretty soon we're doing test cuts that are as good as the CBS stuff, and pretty soon, I'm getting better and better at the lathe, and I'm doing stuff that in some instances is a little better, or I had more response, or this or that. And so we open up the doors, and pretty soon this flood of clients comes in. That has not stopped in 40 years.